All right, guys, I want to go back and review the sections that we did in class before in case you need to review that material at all or if you haven't gotten there yet for some reason. So starting with 1.3 here, this is the first part that we did in 1.3, in which we distinguish between values that describe a population, which we call parameters, and those that describe a sample, which we call a statistic. We also identified what a simple random sample was in this section and confirmed that a sample is in fact random. And we calculate measures of center. Those are mean, median, and mode here. And we're going to talk about why we would want to use one of those centers as opposed to the other. We're going to talk about what resistant means, and we're also going to talk about outliers in this section. So the first thing, population, is the entire group that we are interested in. So if I am interested in finding the average height of 16-year-old boys, then my population would be every single 16-year-old boy in the world. When we're trying to calculate an average, though, having to collect data on every single 16-year-old boy in the world might be a task that's too large to complete. In general, the population that we try to make predictions about or that we try to calculate statistics about are usually too large to collect data from every member. If we could, if our population was something smaller, then collecting data from every member of the population is definitely going to give us the best results. For example, if I changed my population and I said I was only going to make predictions or I was only going to talk about the average of the height of 16-year-old boys that go to Reddington High School, then I could definitely collect data from every single person in that data set, in that population. But again, most of the time our population will be too large. So in those cases, we usually go with a sample. So a sample is a subgroup of the population for which data is collected. So again, it is possible for my sample to be the entire population, but most of the time that's not going to work out. We can instead take any subgroup out of the population and collect data just for that subgroup, and that will be enough for us to make some calculations. Okay, notice when I say any subgroup, it literally can be any subgroup at all. The term sample does not automatically mean that it's a good sample. We will talk later on about what makes a good sample and what makes a bad sample. Now, a sample is literally any group, big or small, that is within that population. If we have data on the entire population, we can use those numbers to calculate parameters. Parameters are numerical facts, about the entire population. One parameter that we usually know is the actual population size. The population size, how many members are in the population, is denoted with a capital N. So I can say like capital N equals 5 million. And that would mean that there are 5 million individuals within the population. Other main parameters that we see a lot are the population mean, which looks like this. The symbol for the population mean, it's the Greek letter mu, and the population standard deviation is denoted with the Greek letter sigma. So whenever you're looking at things in this class and you see a mu, that means that we're talking about the mean of the entire population. Usually we have to predict the population mean based off of a sample. The population mean and the sample mean are usually not the same. Same thing goes for the standard deviation. Since we usually get our data from a statistic, since we usually get our data from a sample, the numerical facts we can talk about samples is called a statistic. So statistics are the numbers that we get from a sample. And again, the sample could be the whole population, but it could also be any other subgroup of the population. So some common statistics that we're going to deal with in this class are sample size, which is a lowercase n. So if I have a population size of 5 million, but I only collect 50 for my study, then my sample size, small n, would be 50. Okay, the mean of the sample is denoted with the variable and a line across the top. The variable is not always going to be x. It can be any letter. X is just the most common. And the sample standard deviation is just an S. It's a capital S. And sometimes we also put the variable that we're taking the standard deviation of as a little subscript down there. That's not required. Let's talk more about samples now. So I said there's good samples and there's bad samples. Good samples are simple random samples. A simple random sample, or an SRS, is a sample that is taken randomly. And what it means to be random is that all population members, every single individual in the population, has an equal chance of being selected for that sample, and all subgroups of the population have an equal chance of occurring. Okay, we must have both of those for it to be a completely random sample. So going back to 16-year-old boys and their heights. If I am going to truly get a true random sample, then every single 16-year-old boy in the entire world would have to have an equal chance of being selected. So I wouldn't be able to limit my selection to just the schools that are close to me. Also, not just that, but I also need to have every subgroup with its own equal chance of occurring. So it is possible that using a random sample, every single individual that I select is within the same school or within the same state. It's not likely, but it is possible because that is a subgroup of the population. And for a random sample, every subgroup needs to have an equal chance of being selected. Again, not all samples are SRS. Not all samples are a simple random sample. Bad samples, samples that are not random, are called haphazard samples. Haphazard samples are not random. These are also sometimes called convenience samples. And they do not produce good statistics. So a good example of a convenient sample, going back to heights of 16-year-old boys, it would be very convenient to only collect data about the 16-year-old boys that go to Redington High School. But that would be a haphazard sample because it would not be random, because not every 16-year-old boy in the world would have a chance of being selected. Now that we know what a statistic is, let's talk about the statistics that we calculate for the center, or the measures of central tendency. So you should have heard of all of these before, so this should be mostly review. Mean is what we think of when we say the word average. If I want the average of something, then I add together all the observations and divide by the number of observations there are. The median is the middle observation. So to find the median, we just choose the one in the middle. What's the exact middle one? You order all your data from least to greatest, and then find the center. If there's 2 observations in the center, like if you have an even number of observations, there would be 2 observations in the exact center, then we actually just take the average of those 2 in the middle. The mode is the value with the highest frequency, meaning it's the one that occurs most often. So how? You just select the one with the highest frequency, the one that shows up the most. So those are 3 different centers. So the big question now is, how do I know which center to choose? How do I know which center to calculate? And it depends mostly on the shape of your data. The mean is what we call not resistant to outliers. What are outliers? Moving down. An outlier is a single observation that lies outside the general pattern of data. So, for example, if I have a quick dot plot here, and there's data over here, lots of data over here by these values, like that. Most of my data is here on this left side. Now, what if all of a sudden I put another point way over here? My median, my center, my mode actually is still right there in this where it was before. My median shifted one individual towards that outlier. But when I calculate my mean and I have to add this really big number to my sum before dividing, my mean ends up getting shifted way over to the right, way close to that outlier. So the mean, we would say, is not resistant to outliers. The mean is heavily affected by outliers, whereas the median is. If one outlier is added to either end of our data set, then the median is only shifted one value to the right or to the left. It doesn't change very much, whereas the mean changes a lot. So if our data is called skewed, or if outliers exist, then we want to use the median. So skewed data is any time where my data is not symmetrical, but it has like a tail off on the end. We would call that skewed. Conversely, if data is not skewed, then it is symmetrical, like this. This is what a symmetrical data set looks like. Its general shape is kind of mounded. So if our data distribution is symmetrical, then the mean or the average is okay to use. If it's not symmetrical, if there's crazy outliers over here, then we're going to want to use the median because it is resistant to outliers. In general, though, the mean does produce the best statistics, or the best predictions, I meant to say, predictions. We're not trying to make predictions about a population. The average is going to give us the best numbers, but it only works for us if our data is not skewed or does not have outliers. Mode is the center that we will use the least. We only use mode generally with categorical data, the data that is not numeric or cannot be worked with mathematically. And that's it.